Okay, so probably my turn now. So my name is Paweł. I'm lead consultant at gravity9. Today, as you can see, we are going to talk a bit about durable functions. But before we get to the durable functions, I would like to also touch a bit Azure Functions at all, what it is, and how we can implement them. But that will be just a short introduction. I want to talk a bit also about the pricing of the Azure Functions, because this is something that confuses many people, at least me. It was confusing for me many times. Whole Azure pricing, it even happens for the different cloud providers. So what are actually the Azure Functions? So this is the serverless solution that allows us to develop our products pretty quickly and with less infrastructure. What it means? Actually, serverless solution means that you don't need to worry about the infrastructure because it is handled by the cloud provider. Rapid development means that you really don't need a lot of effort to actually develop that kind of function because it does not require so much setup. You just create a new project and you can start with delivering like the business logic instead of focusing on some I would say implementation details. I would say this is a really good offer for people that would like to deliver to market the solution as fast as possible, or to test some solution, to create some MVP, to check how that's going to be approved by the business and the people that are going to use it. You can use it as actually in two ways, I would say. You can create a full-blown microservice API based on the Azure Functions. Is it a good way or not? That's, of course, the matter of the use case always. I wouldn't say if you want to build a huge application, it will be the best way to go. But why I say it's a full-blown microservice API, because you can separate your business logic into different bounded contexts, let's say, and focus encapsulate all your implementation in each function. And then you just provide something like APIM gateway on the Azure, for example, which gives like a seamless experience for the consumers or whoever is going to use your API. As I said, it's less infrastructure, so if you'd like to build like microservice API based on Kubernetes, that's a lot of overhead at the beginning especially. So at first, when you start your implementation, you probably want to quickly deliver something to be able to actually present that to your stakeholders. You can always use different languages per use case, per function. We are, of course, limited to like Java, .NET, of course, C#.NET, JavaScript, and the Python and the PowerShell. But here you can, of course, choose what you need, choose what is your actually experience in the team. The other part are background services, integrations. This is something we use a lot in Gravity9. We actually, I think most of our integrations for our customers are built on the Azure Functions. We have webhooks, message bus consumers, queue consumers, database integrations, so as Michał said, for the MongoDB, for example. And you get a lot out of the box. You don't need to install external library to, for example, have a message bus consumer. You just add an attribute that says service bus trigger. You just provide the connection string, and you're ready to go. Before we get to the some sample implementation of that Azure function, as I said previously, I wanted to focus a bit on the elastic pricing tiers you can get in the with the Azure functions. So basically, you can get a lot of for free. So you have $3,000, 400,000 gigabyte seconds, and 1 million executions. This gives you, for your integrations, for some POCs and MVPs, as I mentioned, a lot of flexibility for free. But of course, it's not the ideal, because on the consumption plan, you have some limitations. In the premium plan, those limitations does not exist. So what I mean with limitations, so the biggest disadvantage of consumption plan for me in the Azure functions is that they have a cold start. So whenever the function is not used for a longer time, you just need to sometimes wait until the function will spin up and start working, which makes it not reliable enough for production use case. But for POC integration, that does not really need to probably trigger immediately. I think that's perfect. But here, the premium plan comes to the game with like always-on options where you just pay for CPU, for the memory usage, and you just utilize this as a standard service that you can get on the Azure. But as you can see, we have like 400,000 gigabyte seconds, and this is something that is not really something we use in our day-to-day work to understand. So in order to understand gigabyte seconds, how they are calculated, we have kind of formula that says number of executions by duration in seconds by amount of RAM used in gigabytes. So that means you just need to calculate all those things, and with that, you can predict if you exceed or not the available threshold for free. So let's assume we have like 10,000 executions per month. Each of executions lasts like 1 second, and each execution takes 128 megabytes, which is 0.125 gigabytes. This gives you 1,250 gigabyte seconds, which is really small if you compare it with what you get for free. So that's kind of easy to calculate. I wasn't really aware of that at the beginning of my journey with Azure Functions. So yeah, I think this is kind of good that we can get something for testing, for prototyping with that prices. Right now, we will touch a bit of the sample implementation of the Azure function. So I just wanted to, that's going to be a really simple function that does nothing than logging and returning the OK result. But here you can see how much you need to do it, actually. So this is all code you need to do it without startup files, without the boilerplate code you would actually require for a standard .NET application, for example. And here, you already have the HTTP triggers. You have the authorization level on the function level. You just need to provide the key that is available on the level when you deploy the function to the Azure. And yeah, so to test that, you just do your curl. You get the result. That's simple as this. So this is how the project files look like. So as I mentioned, it's only one C# class, host JSON file that contains some configuration, your local configuration in the local setting JSON, and this is it. As you can see on the top, I called it in process, and this is of course not my imagination to call it like this, because we differentiate two types of Azure functions. We have the in-process workers and isolated workers. The differences between those two are like in-process worker runs in the runtime of the Azure function, and you always get what Azure delivers to you. So you need to use latest libraries, latest framework rather than libraries. And you don't always want to move as quickly as, for example, a new .NET gets released, because you want to wait for the next .NET. You actually want to wait for .NET to be mature enough to move and upgrade your function. And here is the isolated worker that comes to the game, and it gives you more flexibility. It gives you all the control on the dependencies in the framework. And actually, with this, you decide if this is going to be .NET 3.1, like .NET Core 3.1 or the newer one. What is also important, the isolated worker is something that Microsoft is encouraging people to do, as they are going to sunset the in-process worker probably this year or maybe next year. I'm not 100% sure. So eventually, this is what you're going to do. So work on the isolated process. There are differences in the implementation. So isolated worker, first of all, gives you like out-of-the-box dependency injection without any additional configuration. So because it comes with the program.cs file that actually allows you to configure DI as you do it in the standard .NET application. You just get the Azure defaults, Azure function defaults built in, so you don't need to think about things that I mentioned before, like authorization, authentication, etc. at the start. You, of course, don't need to bother think of those folders here, because that's the screenshot from the application that I'm going to demo at the end. So the main difference is that you get the program.cs, and of course, the code looks a bit different. So I don't know if you see this. Yeah. So basically, in the previous function, we had like function attribute that makes the function be function was called function name. You just here provide the function. So these are kind of semantic changes. Also, like isolated worker requires you to provide in the HTTP trigger HTTP request data instead of standard JSON object, for example. You need to deserialize that later on. And then you also return like HTTP response data. But yeah, there are more like differences because they upgraded the libraries, they changed some name conventions, etc. But yeah, from the implementation standpoint, not a lot has changed. But yeah, I mentioned many times HTTP trigger. So maybe I will just get to the point where we talk about triggers. So the triggers in the Azure functions allow you to run your function based on different inputs. So we have the HTTP trigger, as mentioned, which is, of course, standard HTTP request. We have queue, service bus, event hub, which are listeners to different types of messaging systems. We have a timer where we define the time, how often the functions will be executed. We have a blob, which actually reacts to the blob events, and of course already gives you some context of the file, for example, that was changed. Cosmos DB, of course, reacting to the Cosmos changes. The last three are strictly connected with the durable functions. which is orchestration, entity, and activity. To those, I will get soon when we will be talking about application patterns. But basically, these are the most common, but not only ones. And probably they will be even extended for more resources. The important thing is that you cannot have more than one trigger on the function. So it is always only one. If you want to, for example, execute the same logic, you just need to create different functions with another trigger that just share the business logic. And here we got to durable functions. So durable functions is a feature and the concept actually to resolve complex business processes. It gives you the possibility to actually write stateful functions with orchestrator functions, with the entity functions and the activity functions. I will just get to those. Behind the scenes, the runtime of the durable functions manages state and all the triggers for you. So it's another advantage. You don't need to actually think of many infrastructure or many things. How to, for example, connect one function with the other, how to connect the different services together. You just get it out of the box. So yeah, as I mentioned, we have multiple languages supported. This is the same for durable functions because they are just extending the Azure functions, not changing their concept. And yeah, here I'd like to get to the application patterns. So the application patterns are like 6 defined by Microsoft patterns how to use those Azure functions. But actually, this is not like you have chaining, for example, and you cannot change it or use it different way. It's rather like 6 propositions, and those 6 options you can merge, you can try to adjust, customize to your needs. So chaining in the Azure Durable concept is kind of straightforward. So you have multiple functions. Each is they are executed in the sequential order. We are executing first, getting the response. So kind of simple. But why to use that at all? So the most important thing in those is that actually, again, you don't need to think about the clients, HTTP clients or something. You just get the context of the orchestration and you call those functions with, using their names, and that's it actually. So then you also, as you can see, you can provide the input. Then it gives you the response. So I mentioned before HTTP triggers, not HTTP triggers, sorry, durable functions triggers. So we have the orchestration trigger here, for example. So orchestration trigger this is how we mark our function that orchestrates the whole flow we're building. So it has the context, and it is responsible for calling different functions, awaiting their responses, awaiting some input from the external services. We will get there. So this is the first of those. And what is this orchestration context actually? So the orchestration context gives you this confidence, like whenever this function, for example, fails, like, I don't know, maybe virtual machine that is hosting it will stop working in the middle of execution, like after the first function was run. So the orchestration context will make sure that whenever the service starts again, it will start executing from this point where it stopped. So this is one of the core concept of the durable functions. Yeah, and the other thing is, of course, that it easily allows you to connect, communicate with the different functions in this whole flow. The question may be where the function actually, how the function or how the context know where to start if it was disposed and restarted. So the functions keep their state in the table storage on the Azure. So there you can find like the whole, like each step that was executed is written down to the table storage, where you can actually go there and see what was the last action that happened in this orchestrator. The next pattern is the pattern fan out, fan in. So this pattern actually relies on running multiple functions in parallel and then aggregating its result and then, let's say, sending the data to the another function. So also a pretty simple flow, pretty easily resolved with one function that does all those things. So yeah, pretty simple example here. Yes, another pattern I would like to cover is, of course, async HTTP API. So this is, we are getting to the more complex solutions here. So the async HTTP API actually handles for you the status of the operation. So it's for example, for the long-running processes, right? So you have a function that starts execution. Then there is a function that does the work. But you have the other function that gets you the status of the current like gets you the status of the process right now. Thanks to that, you don't need to implement the whole difficult logic behind the scenes that you would need to get the information. If this operation is finished or not finished, you would probably need to, by your own, write it somewhere, like, save the state, whatever you need to get this. With the durable functions, you just write the function that starts orchestration. So it contains like a durable task client that runs our orchestration instance and returns you create, check, status, response, async. So this returns you the whole JSON with different actions, that one of them is to get the status. This is the orchestration function. So this function, of course, does the job. This simple sample from the Microsoft website where they just call the same function 3 times, and they get the result that is then aggregated into the list. And what is important, oh yeah, so before I go, so this is this simple function that is executed by the orchestrator. Of course, logging, you can do something more, like I would say, complex than this. But here we get to the activity trigger. That was the another one I mentioned in the list of the triggers. And the activity trigger is created for all the functions that belong to the orchestration and do some work. They can connect with the external services. They can do some operations. They can send, I don't know, messages, whatever you wish. But this is how we actually mark the function to be able to call them and then also register it in the orchestration context, so we can always come back to this function when it fails, when it restarts, as I mentioned. And probably you don't see this because I thought that it's going to be better resolution, but this is the output of the, this is the JSON that is returned when you get the status function. And here is where you actually get, this is what you get when you start the function. So this create check status async or something like this. So you get like JSON file with different actions you can execute on this long-running process. So you have one of them is status. You can also send event to this long-running process. You can terminate that process. You can suspend it. So and then you can resume it if you need. And this is the response of the status query. So as you can see, it contains some interesting information. So basically, this is already, of course, completed. If that would be still running, you would see like in progress or running, I think. This is the runtime status. But also, you already get the output, so you don't need to call the another endpoint to get the status, to get this output or something after you learn that the runtime status is ready. So yeah, this is the async HTTP API. Another pattern is the monitor. That's kind of simple. You just run the process and monitor its result. When it's, when you get the result, you just do the action. So for example, here we have the function. This is the orchestrator, of course. It starts some, so it runs it creates like intervals and expiry dates. And these are like, you see them as red, of course, because this is just a sample. I didn't implement those functions. And here you have like a while loop where you actually call the activity to get a status. Then if you get the status completed, you just, for example, send the alert. If that does not happen, you create the timer and wait until the polling interval is finished. Yeah. So here we have human interaction pattern. So this is kind of one of those processes that is always hard to automate. So whenever you have automated process and you need to have a human input in that, because someone needs to approve something, someone needs to check or decline something, it is always tricky because the people are never, as responsive or as fast as like cloud services. Sometimes we need to wait. Sometimes we need to think of compensation logic, for example. Let's say you have sent a request to approve your holidays. Yep. And let's say someone, your HR manager, is not approving it. And what happens if he does not approve it for, like, I don't know, 7 days? I would write a function that will approve my my holidays, of course. So this is one of those things that you need to think of how to do those. And here is the solution for that. So again, simple code, nothing nothing complicated, nothing, no like external dependencies, no dependencies of database or something. What you do here? The orchestration, first of all, request approval. Then we create a timeout, and there is a function here that actually waits for external event that comes from the other function or whatever raises this event, but I would assume that we can say it's the other function that just raises the event, and the approval event comes, then the timeout cancels, and we just say like, okay, let's continue with the process. But if that does not happen within the time frame, like we are waiting here for the approval event or durable timeout. Whatever goes first, we just check if that was the approval or the timeout. If that is the timeout, we escalate. So you can always raise this event just from standard curl, whatever, Postman. You can have some client that just runs this, raises this event. But why don't you want to do this? Because actually, you need to know, like, for example, instance ID to know where to send the event. And with the function that is connected to the durable context, you can actually it will just automatically merge it with this durable context. Yeah, so this is a function that raises event. Another pattern, it is the last pattern I want to cover today. So this is the pattern of the aggregator. So this pattern would be rather used to, for example, if you have some entity that you want to be built from different data sources. Sometimes this data is not coming at the same time. Sometimes you need to wait until all the data gets sent to this function. And with this aggregator, you don't need to think of actually concurrency issues, because normally if you would have like something saved in the database, you need to ensure that this entity that is being updated, the two different functions are not modifying the same entity, so you need to think of transactions, etc. And here, you get it out of the box. So actually, all the events that are coming are just executed one by one, and they make sure, so the runtime knows to run them and lock the entity for one execution. So the implementation is, for the implementation, we use entity trigger. And this entity trigger have two options. So you can run this function with the option like fire and forget. So you just signal the function and you just proceed with your business logic later on. Or you can call the function and wait for the response, which is, of course, like async programming. Yes, and in our demo that I'm going to do in a moment, I would like to merge all those different patterns into the one. So this is the time I need to sit. Oh no, yet not. I have two more slides, so probably. So our use case, our demo application, it's going to be sample kind of simple. This is something I built some time ago in one of my projects. So this is the application that notifies support whenever alert is raised by some external service. So our assumption, error occurs, alert is raised. We want to send the notification, await for the response from the support. So here is the human interaction we just talked about. When the response is received, just stop the orchestration. When the response is not received, within the period of time, we just escalate to another contact, and the loop is going on until there is no more contacts to see. In order to do that, we need to build different, one function project, but with different triggers. So the green one in the middle is the notify support orchestrator. So this is our main orchestrator that is started by notify support HTTP client. So these two, HTTP client and callback client, these two functions are the functions that are called externally. So you will see that they have no any triggers like activity, entity, or orchestration trigger. They have standard Azure function triggers because they get input from outside. On the top, you see get context activity and send notification activity. Those two functions are the activities, so they will be marked as activity trigger, and those are executed within the orchestration. And the send notification orchestrator is the another orchestrator, so this is kind of, I think, important part here, that you can have multiple orchestrator in the one durable project. The difference is that the green one is our main orchestrator, and any other that we build is sub-orchestrator. But yeah, so it has its own context, but this context is also then connected with the context above. And let me open the project now to show you how easily we can build it. So I don't know if you can see the code quite clear. How is it going there?
It's good. Yeah.
It's okay? Okay. So as you can see here on the right side, we have all those functions I mentioned. So we have the orchestrator, we have the clients, activities, and we also have the entity, which is used to preserve the state of our function changes. So in order to write that kind of stuff, you just build your orchestrator, which is pretty simple. We have we get the input from the notify support HTTP client. So as I mentioned, this is the HTTP trigger because here we get the data from, in my case, from the postman, but of course, from some external system. And this function starts our execution and returns us this check status response. So we will see soon that we will get the JSON with different possible actions. Here we just start the orchestration, and the function forgets about what's happening then.
Explain from where we are getting the client thing here. I don't see it in our defined get parameters function.
Oh, so it's in the parameters
okay.
function. Yes.
Cool.
Probably I should do it like this. At home I have a bigger screen, so it's like, you know, it fits. So the notify support HTTP client calls the notify support orchestrator, and here we get the input that we just passed from the HTTP client. What the orchestrator does, it loads the contacts from the activity function. So the activity function is kind of simple. I don't have any connection to database. I just have a simple plain array that is returned. But yeah, that of course, just for the simplicity of the implementation. And then our orchestrator call the sub-orchestrator I mentioned, which is the send notification, and then awaits the response from the sub-orchestrator to do the another actions. Or if it gets like callback, then it means you know, the orchestration stops, and we log warning here that it's completed. After that many calls here, so the send notification orchestrator is actually this one that is sending the, like calling the send notification activity. And yeah, the send notification activity is just, of course, also just the logging to see in the console that it was called. So when the notification is sent, we also await for the event to be raised here. So until it's not, if this is not raised within like time between retries, we just throw exception that task was canceled. I mean, runtime throws this exception, and we do the retry for 3 times actually in this implementation. But here we go with the entities and the stateful implementation of those functions actually. So we signal entity, as I mentioned, and we tell the entity with this ID to set the instance so it's saved, so the callback knows what is the actual instance to return to. And yeah, here we call the activity as I mentioned, and then we proceed with the process. In a moment, I am going to run it, but I want to just explain a bit on this entity trigger once more. So here we have a class, and this class contains this instance ID we are going to save in it. And here we have possible operations on this instance. And these operations are then sent as a strings in the signal entity or call entity. I can do it like this as well. But I don't want to actually await the information that it was set, because this is not relevant for the orchestration. It just signals it and then awaits. For the callback from the callback client, that is then handled by, of course, support person that says, okay, I've read the alert, I'm going to do something with this, please stop the orchestration. So let's run, and let's hope it will work, because it was yesterday.
This will create several functions, or one?
Yes, so each of those, like orchestrator, HTTP clients, and activities and entity, these are all separate functions, but they lie in the same project. That means you can deploy them together.
That's why I'm asking, because you're referring to the names of the functions like objects, right? So they were.
Yes, because this is kind of the, this is the kind of the naming convention, of course, like entity, because that probably doesn't mean function for the from the standard standpoint. For example, for me, entity is something that means, as you mentioned, just an object that keeps the state. But in this case, everything is function. So yeah, all of those will be functions within one project. On the Azure, you could deploy it to one function app actually. But yeah, let's start. I need to just alter the configuration. Okay.
While it starts, so if one of those functions were outside of this project, right, you would call it slightly differently by name?
No. All the functions need to lie in the same project. If you want to, because they all are connected with the same business process. So if you want to,
so let's say I have some extra function somewhere else deployed by a different team.
Then you need to, for the orchestration, they are external. So for this connection, you need to have standard, some HTTP connection that you would like to address.
One of the triggers you mentioned to call that external.
Yes, yes. So you just need to build it like custom stuff, I would say, because here we focus only on. So by name, you can call only the functions that belong to the same context. Oh, maybe that's the answer. So yes, so we have all those functions up and running. As you may see here, all those functions are registered. The only thing is that only the two, so callback HTTP client and notify support HTTP client, are actually available for us because the other or have those orchestration triggers that we cannot just manually run. So yes, we have we want to notify support that something happened in our application. So we send the message. Message is, of course, message with the severity 1. This is, implementation detail does not matter anything here. So I run the function. I got all the statuses, all the endpoints that I can use for this orchestration. So I have send event, I have status get query, and this is something I'm going to click now. And here you can see that my function is running with that kind of input. So this input was generated by the notify support HTTP client. It was sent to the orchestration, and we are running, waiting for the response. And in the logs, you can see that our function sent the notification to this number with the message. It sent it second time because it didn't get the response within 1 minute. So it is actually well, it didn't get the response for the 3 times. Then it uses another number. So if I want to just say, okay, I get the notification, I send the message to the callback HTTP client as a support person, and my orchestration just stopped on this number on the first attempt because it had no time to execute more times. But what happens if I never give the event that I found let's say I'm the, of course, support person, and I'm not going to respond for the user or system alert because I'm lazy and I have a weekend. So it will wait. It will send 3 messages to one, 3 messages to another one, and 3 messages to the last one because we have 3 contacts on the list, and then it will stop the orchestration. Right now, what we do in the business logic is that we waiting after the first message, we wait 30 seconds. After the second message, we wait for 30 seconds, and after the last attempt for that person, we wait only 20 seconds because this is 60 seconds divided by max notification attempts, which is 3 at this point. So yeah, we need to wait a bit until it will finishes, which was, yeah, so this is the first. Or maybe I can just reduce the number so it's easier. This is easier for you. Oh, this is something maybe. So now we will just wait 10 seconds for each iteration. Okay. So as you may see, I didn't click anything yet. It already started with number ending by on 1, which is the second phone number, because first one is ending on 0, second on 1, and last one on 2. Even though I stopped the function, stopped the debugging, and restarted, and it resumes from the point it was stopped. So the state was saved in the Azure storage table storage, sorry. So the 1, 2, probably one more message, and we will see that also the process will be completed, but this time with the status failed. So it's callback not received, and we can see here status query. yeah, so the status was completed. And we get also the last input that was provided for orchestration in our sub-orchestration. So it went through every single contact and never get the callback. Yeah, I think, let me just do it like this. Oh, no. So yeah, that's everything from me. I don't know if you have any questions. If yes, feel free to ask them. Yep.
Okay. Yeah. So I saw these triggers which are there, like event bus, event hub, from which are mostly from the Azure side of this activity and orchestrator HTTP. So what if someone wants to trigger it with some open source tool like Apache Kafka or gravity9 or something like that? Will it be possible to?
So so maybe I will repeat the question as I was. So if it is possible to use like external sources different than Azure, right? So for those, there are custom implementations. You can install them. I think Microsoft also has some. I don't want to like say lie to you, I would say, but I think there is. For a couple of them, definitely there are extensions, not only for the Microsoft services. But yeah, I'm not sure which one. I'm happy to find it for you, and I can provide you the answer later on. So I will display my email if anyone would like to later on ask the questions or something. So yeah.
Yep. So you mentioned that each orchestration is associated with storage table, right? Mm-hmm. And it's something that you are additionally charged for. So there's a difference between pricing in stateless and durable functions.
Yeah. So the question is if we are charged additionally for the table storage in durable functions whenever in comparison to the standard Azure functions. So yes, of course. So we basically pay for each resource we use, right? But you can always set up some kind of, I would call it, I don't have a word right now. So for some, you can like have some retention on the table storage or something. So you like rather not to keep those table storage data too long because that's rather not needed for you, I believe. It's something that just needs to be saved for the Azure function to know when to start, from where to start. But I would rather advise to have some retention there.
I have some confusion between the entity trigger and the activity trigger. What are the main differences between those?
Okay, so yeah, what are the main differences between activity trigger and entity trigger? So entity trigger is used to keep the state because the function. If you don't want to save the data, for example, to database, but you want to preserve the state of some object in the in the context of the whole orchestration, you use the entity trigger. But if you want to just run some operation that can, for example, execute something in the external system or just do some operation and return the response, then you use the activity trigger. So the activity trigger should be treated as a normal standard function, which is called by the orchestration, and the entity trigger is rather the place where you preserve your state. So it is. So this is kind of implementation of the actor model, maybe you know, where you actually instead of modifying the object like a class or something by your own, you just signal, you send the data and saying like set this property of that object to, I don't know, 1. Yeah? And the another operation comes in, okay, increment that to 2, instead of just using the standard operations like set. And that also gives you this confidence that when this entity is modified, it is always like the durable context makes sure that all operations are executed sequentially and not at the same time, so you have no concurrency issue.
So you were presenting an output from the get endpoint, and there were two properties: status, it's completed or in progress or something like that, and the second one, output. And is it possible that we will get partial output, or it's only one fragment before completion of the function?
That's a very good question, and I'm not sure. I haven't used that, to be honest, and I didn't verify that. But yeah, I will check that for you. If you can maybe later on come to me and just leave me your contact to you, I will find it for you.
I'm curious about concurrent access because you said you showed a few patterns here. One of the patterns was very obvious. You call it just forget, right? Let's take this one as an example. So you get multiple triggers to the same Azure function. That's the one scenario. But the second was you showed like multiple arrows coming to the same Azure function, right? How those two
aggregator.
Yeah.
So. I just need to understand the question because I think I don't know.
So basically, when you call a function, it gets its own let's call it hot start. It does the thing really fast, right? You call again. So if you go do it in concurrent mode, again it behaves safe. You start one or multiple depending on the setup, right? Azure functions when there is a huge traffic. Several anyway. But then I don't get the point of this aggregator. So how it behaves when it's triggered. So once triggered, it starts working, and there's another input there.
So we can imagine the situation where you, for example, so the question is how the aggregator, how the data coming into the aggregator comes to the same function, actually, right?
Yeah, indeed, because you have multiple arrows.
Yeah. So this is where the durable context comes to the game, the durable actually runtime. So let's imagine you have, I don't know, like people are sending every employee is sending a spreadsheet to some, to some main place where it's, and the function, the function is going to, pull some data from each of the those Excel spreadsheets in order to, for example, I don't know, aggregate it somehow and then, give you the output, right? So how the function works, how the durable function works is that you, for example, let's say I started my job at 7 a.m., so I send my spreadsheet already. It comes to the aggregator function, and the aggregator function gets executed. And then it is goes to sleep, I would say, or just it is turned off. But your current state is already saved in the table storage. And whenever another employee comes in and sends its spreadsheet, the function comes up and running. Okay, this was the last state. The durable context stopped. We already have one spreadsheet uploaded, let's say. We have another spreadsheet that came right now, okay, so we are taking data.
Queuing in front of that? There are multiple requests going at the same time?
No. I mean yes and no. I mean yes and no. So in the behind the scenes, maybe that's a good word. Behind the scenes, you have the durable context queues the operations. So this entity is not changed by multiple threads at once. But the entity belongs to one function, so actually it is not possible to share this entity between the functions, unless you have like really huge traffic and multiple functions get started, because this is how the scaling works. But so then they actually access the same entity, so they share the context, durable context. So the functions modify the same entity, but everything is queued. So what is first modifies first, and another operation modifies the second. So there is an order. So not all the operations try to modify the entity at the same time. I hope that answers your question.
I will bother you later.
Okay. Yep.
Behind the scenes, there are some queues, and every message from is marked by let's say transaction ID, and using a hash function, message goes to the corresponding queue based on the modulus. And that's how one function reads all the messages from from this transaction. I mean, if you have lots of them.
Okay.
And I'm curious if you have very mature project where are lots of functions there, and imagine you're a newcomer and you have to understand what's going on here, and you have, let's say, 30 functions, and I've seen the code, and it's not easy to grasp how this code connected.
Yes. Yes.
So if you have seen major projects, how the code organized here?
So yeah, so how to actually get the newcomer into that huge project, which is kind of complex, and the connections are not that straightforward, right? So that's completely true. On the other hand, when you, for example, execute the function, like let's go back to here. So you kind of, for example, here you kind of define which function you call, right? And in the complex function, you would rather have different projects for different business processes. So basically, you would not expect probably to have like 30 functions or 50 functions, probably. But yeah, of course, I can imagine that that there can be really complicated workflow. So yeah, in that case, I'd say this is only what we have, right? So we can, kind of read that from the names, the activities, for example, we call, or the entities we call, or signal, or what the events we are awaiting, and then you can also find which, for example, function raised the event, right? So this is always the matter, I think, the organization of the code, but sometimes in the huge projects, I believe that kind of stuff must be somehow documented, right? Because I don't believe like you get 50 functions and, well, whatever. Yes?
So what if one of the function, because this is kind of a thing where a person might try to follow some kind of a design pattern where single responsibility should be given to one particular function. And what if the size of the function starts increasing, like more requests are coming for that particular pattern, like for that particular function, and how do you segregate like further to make it like more smaller function? Because function shouldn't be of that big size, which I believe is a kind of a small block. So how do you segregate like in that way?
So how do you segregate the functions to make them small, right?
Smaller.
So basically, I think this is always the matter of having, good distinction what the function. Well, I mean, as in the the sample I was presenting. So we have the function to get some data. We have the function to do something. So it's better always to have like 10 functions modifying, like we have this chaining, right, for example. Or we have the fan in, fan out that can, you can run in parallel different functions. So I think I would say that this should be, that's on the level of the designing or developing that kind of function. You should take this responsibility and say like, okay, this function is already big enough. I don't want to extend them. Maybe I can, call this action differently because, it really do not belong to this previous function. So I think it's always a matter of, segregating. The same as you, for example, you build the object, standard class. You have different operations on that class, services or something. Then you always need to somehow divide those methods, I believe. Yes.
Yes. Did I get it correctly that durable functions are we can consider regular Azure functions, just some additional infrastructure added on top of them? Or it's something working very differently from Azure point of view?
So yeah, so the question is if the Azure Durable Functions are the same but extended Azure Functions, or if they are completely different. So from the implementation and the conception standpoint, durable functions are built on top of the Azure Functions. They are just the extension. Yeah, and they are just giving us more options. But yeah, you run them in the Azure, you run them the same, so you just deploy the code to the function app, and yeah, that's it.
I mean, it means that theoretically I can implement the same functionality with what I implement as durable functions. Just I will need to manage all these stuff like context.
Yes, so this is what gives you the durable functions, right? So you don't need to think of the context. For example, the function I was showing before, that is, for example, giving you the status, right? So you don't need to think of how to manage the status. Do I need to get this from some database or something? Because of course, underneath, it's always, these are only the functions that have some runtime that, does it for them. So, so they save all the executions in the table storage. You could do it by yourself, of course, but yeah, here you just get a solution you don't need to pay for. So,
actually, this question is quite good for what I asked about concurrency, because I don't think you can achieve the same thing with regular functions when there's multiple workers, because there is a very complex problem of handling the state changes, the concurrency, modification. Like, can you do that? You have several workers, then you have to work on
actually, I think you can if you will use some queue or message path and
yes.
in such way.
Mm-hmm. I think it is just a matter of how much time do you have.
Well, that is the fact. But, well,
yeah.
Okay,
so I think it was more like a concept question. If if this is the same but with additional things that you don't want to write by your own, or is it completely different? But it is the same, but with all those.
Let's chat about the answer, because I have a different view here. Because if Azure Durable Function, they have some kind of queuing mechanism in front, so the load is controlled by the queuing mechanism in front, right? So there is an order. But if you want to implement your own queuing mechanism after the function is executed, then you have a parallel access to multiple workers, multiple Azure functions, and then you have to manage the same order to the queue, which is after the function was called.
I mean, but this is how it works, right? So, for example, you have this entity that is getting changed by multiple data incoming. So it just gets queued, right, on the list and on the queue.
Yeah, but this happens before it gets to the context. Right?
No. So it happens. So let me go back. No. I think I had it here. where was that? Here. So basically, you have the Azure function that is called dispatch async, right? And I mean, the name of the function doesn't matter, but the entity trigger means that this function is responsible for modifying some stateful entity that should be accessed by, can be accessed by different functions within the same context, right? So whatever you, so actually, all those messages before they get to the entity trigger, they get queued, but that's kind of, you could probably implement that in your own way, because before they get to this queue, which is before this function, they already get to the orchestration function, right? So they get to the function, you have like some orchestrator, like this, right? And this, so multiple inputs can come here, and then you have like context.entity, signal entity, and this is the moment you queue actually your data. So of course, it queues before the function that modifies the entity, but it does not queue before it starts the process at all, right?
Okay.
So I think conceptually, it is the same if you could build like your own queue, like message bus queue or something, and then you had like consumers that consume the messages in the order, I think. But yeah, we can talk. Yes?
Can you share please the presentation or?
Yes, of course. I don't know where to share it, to be honest. Where can we share it?
So let's upload it maybe to our GitHub.
Yeah, okay. Yeah, source code is already there. So yeah, you will find out that on our GitHub, gravity9, I think. That's it, right? Yeah.
There are 2 methods related to it that you contribute.
Yeah. Okay, if that's it, so let's have a beer and pizza. Thank you very much.